Yeah, thank you very much. And I hope you had all first a good start in the day, in the first sessions. And today the topic I bring, it's my second time here presenting at the ContainerDays, third time attending, I guess. And I decided this time to go into a bridging topic. So my first question to you would be, since we are bringing your two topics together, who of you comes to this session because of the word platform engineering? Nice. And who comes because the word green exists in the presentation? Okay, that seems like a good mix. Also some matching. So it's precisely on the intersection between both that I am doing this session today. And I will go through a few topics, not many. There are a lot of topics that one can talk in this area, but I will start with a short introduction, then go into the idea of what is GreenOps and why we need it, then how we gather data for sustainability, and then to the topic of platform engineering, how we can leverage this whole idea of green IT through platform engineering. So I welcome you to this intersection of innovation, sustainability, and mobility. Why mobility? Because coming from the Deutsche Bahn, we obviously are a company that is focused on mobility. But before we go to it, I will tell you something short about me. Actually, while I've been doing product owner in the Deutsche Bahn currently, my original training was as environmental engineer, and I did attempt very often to save the world in this area. But as you probably noticed, it's been unsuccessful. Still, I continue doing stuff like starting, for example, with some colleagues, a hosting provider that attempted to do some energy saving, ecological hosting, also based obviously on free, libre, and open source technologies. And with this, I ended up being contracted as DevOps engineer at the DB Systel, which is the digital partner of the Deutsche Bahn. And since there, I've been working both as DevOps engineer, then later as product owner, and more going into some architecture and community and strategy topics like digital platforms, green IT, and the edge. What also brought me to the Deutsche Bahn was my passion for sustainable mobility. Bicycle, but then also trains. I was traveling, I think, over 30 times with Interrail around Europe. And so if you need any tips for traveling with trains at an international level, you can talk to me afterwards, and I'm happy to share my experiences because international train traveling is not always easy, unfortunately. And of course, the main aspect why we need this presentation here is, as you all know, our world is not in the best shape. We are experiencing more and more ecological disasters, some of them pushed by, or many of them pushed by the climate change. And at the same time, there is a strong political will at least, to really reduce the growing temperatures and capping them at 1.5 degrees. These are the last agreements. But we know the operational part of it is far from being successful in really setting up the global warming up to this level. So I already talked to about the Deutsche Bahn. I think for the German people, we don't really need a presentation because I expect that more people have traveled and used the Deutsche Bahn trains than have an Audi, right? How many people have traveled with the Deutsche Bahn? See, we always win. That's the nice thing, if that was a competition. But yes, that's sustainable mobility. And the Deutsche Bahn group is not only in Germany, but also worldwide in logistics. So there's also this initiative. There's a big strategy that Germany needs a strong rail system. And fortunately, we have in the last years seen an ever-growing interest in supporting sustainable mobility and the rail system in Germany. And this was unfortunately not the case in the 90s. We had a lot of investment in this field, which we all then feel when we are traveling with the train. But that's really the interest that's growing. And one of the reasons is precisely why we need a strong rail system, the climate aspect. And it is recognized that unless we shift the traffic on a massive scale to a strong rail network, we will not be able to achieve our climate targets. So focusing on digitalization also for bringing more rail traffic into the tracks and for getting it more automated so that trains also can ride more efficiently and be more prepared to address disruptions. These are all things that involve a lot of technological investment and digitalization, but at the same time, they bring with it an aspect which is an increased amount of emissions. So computing has been growing. We know from the data centers, this is the figures from 2015, but there are also other studies from the International Energy Agency, for example, in 21, that shows this growing trend of electricity usage in data centers. And even the middle scenario, which I would find almost unfeasible in face of the growing machine learning models and so on, is one which is exponential growing. And so there is a need to effectively, in our organizations and in the cloud computing, to bring more attention to this and to look into also bringing the developers into making a change on how software is being operated and run on the cloud and on this hardware. So moving to this next point is about how actually developers, and this is the main focus of my presentation, how can developers actually become key stakeholders for climate protection? And I believe that this is the most important aspect. So of course, there's a lot of also the previous speaker from Audi was saying you have all this process, you have all this management level and so on. But if developers are not involved in it and do not have established good interactions with operations, for example, they will not be able to so effectively address these issues. And as DevOps have laid the foundations for efficient software delivery, we have another level which is called FinOps, which deals with optimizing cloud costs and financial management. And then GreenOps comes as almost a new layer, which incorporates this environmental sustainability into the technology operations. And in the end, GreenOps is about informing, optimizing, and operationalizing best practices and for reducing resource usage and carbon emissions. So we are always talking here about, at the end, almost always about energy and CO2. Why would developers be motivated for doing green IT and green ops? I believe that there is an intrinsic motivation from people altogether that when we have a problem, a complex issue that we are facing, like global warming, that we want to, in some way, support solving it, tackling it. And I believe that developers that come to the Deutsche Bahn have even a stronger motivation for this. Maybe not all, but I mean, it is nice when you are working for a company that you know is providing a positive role also in addressing the climate challenges. So we also see this actually in our company. As we started last year with an initiative on green digitalization, and also in the Systel, there was a team group on architecture that started. There were immediately a lot of developers joining these initiatives and contributing in multiple ways. And there were small projects emerging that would, for example, help you to a small tool to let you measure what is the efficiency of your website and the CO2 emissions. And so when you make a change, you can look how it has optimized or not your website. And there's a lot of interest in this area. So even in their free time, let's say, developers are just joining these initiatives. Of course, there's also a growing attention by management, which is also needed to support that these initiatives become supported also through financial, that they can have a business, that they can then be distributed in the whole organization. And the motivation for management comes obviously also from these climate targets from 1.5. There's new regulations coming. There's investors are more and more looking into the environment, social, and governance indicators. And so companies try to align with these ESG frameworks and to, in a way, be able to report that the company is green. And while we do have a lot of these already set up in procurement, for example, and buying hardware or looking for that our providers are sustainable, we have very little nowadays on IT itself, on the operational part. And the reason for it is that while granular billing data is relatively easy to find, the step towards getting real-time energy and CO2 emissions requires that we have a few more steps in it. So from the resource usage from the cloud, we require a power estimation model. So we need to know if I use a portion of this hardware with a certain load, how much approximately will it generate in energy? And afterwards, when we have this energy, we need to estimate the carbon intensity. This step is actually quite simple, but as we will see, and then we need dashboards that bring us to understand how are our workloads performing in this sense. So in a sense, it's also about information and controllability. It's like you have your DB Navigator, this application from the Deutsche Bahn for those who don't travel by train. Those who travel by train hopefully have it because there's no longer the plans on the on the train stations. And even if a train is late, you can find the next train because you have the information for it. And you can even decide if you go on train A or B, so you have a certain amount of control. And this is important that we also bring this to developers in this sense. And data is not just about informing, it's also about empowering exactly this change. So let's navigate a bit into this landscape. And I will start with a short video that shows a bit metaphorically this, maybe of you will know this sketch, but they show us why maybe getting this environmental data, these energy measurements, not so easy.
What is it?
This, Jen, is the internet.
What?
That's right.
This is the internet. The whole internet.
Yep. I asked for a loan of it so that you could use it in your speech.
It's so small.
That's one of the surprising things about it.
Hang on. It doesn't have any wires or anything.
It's wireless.
Oh, yes, everything's wireless nowadays, isn't it? So I can really use it in my speech. What if someone needs it?
Oh, no. People will still be able to go online and everything. It'll still work.
Oh, good.
I tell you, you present this to the shareholders and you will get quite a response.
Can I touch it? Ooh. It's so light.
Of course it is, Jen. The internet doesn't weigh anything.
No, of course it doesn't.
Hey! What is Jen doing with the internet?
So the idea here is how do you actually weight the internet? Because when we are on FinOps, we are still addressing artificially created price tags and so on that we say, okay, a block of this costs Y. But addressing environmental aspects of this technology is about transforming something which is highly virtual and understanding what is physically behind these highly virtual components. And this is a challenge because it brings a lot of a need to create a lot of inferences and to model all this aspect. So what have been our cloud providers doing? Providing us with carbon footprint tools. So we have from AWS and from Azure. And if any one of you who has used any of these tools here in the stage, yeah. So the two persons that have used it will have seen that. Well, they tell us a very aggregated view of how many CO2 emissions your account has. But they don't tell us with a high level of granularity to which service it was allocated. I cannot filter by labels. And if they at some point bought carbon compensation, then your emissions will be from 1 month to the other 0. And of course, this is not the type of information that we need to be able to control and to improve our applications. So there are initiatives for accurate measurement from the community. One of them that I found very interesting, one of the first I found was the TEDS Engineering EC2 carbon footprint estimator, which took hardware and some kind of reverse engineering, trying to understand based on the processors that are there and the load with hardware that they got, what is the energy consumption. And so they can tell you on the different scopes how much CO2 emissions and also the energy usage that is beyond it. Another initiative is the cloud carbon footprint, which goes precisely into, based on the usage data, also with their own model, then converting this to energy and CO2 emissions. What is interesting then is that we try to do is we actually want to have a mapping to the concrete applications. And here we intersect with enterprise architecture management. And what we see there, there's no pointer, but we get the cloud usage and cost data source from your cloud provider. Then there's this tool, for example, the cloud carbon footprint. And what we want to do is then to map. So we have this tagging from the cloud resources. They all have a tag that is explicit to one specific application, because there are accounts that have more than one application. So with this tagging that comes from enterprise architecture management, you actually can map the energy and CO2 consumption that comes from the cloud into these specific applications. And this can help that we bring into the enterprise architecture and things like the ESGs to bring an overview that is then, again, interesting not only for developers, but most especially for architects, decision makers, to see where do we have the biggest impact, which are the applications that generate the most emissions and that they have the highest potential to optimize. Now we go into the point of how actually platform engineering plays a role here. And so with this information on where we get the data, how we can get the data, still a bit limited, let's see some patterns of the platform engineering. So just a short notice that the main platform that I have been working on is developer experience platform. Meanwhile, there is probably in every middle to big company, even small companies, some kind of internal development platform. That's ours. We have around 10,000 users, and specifically on Kubernetes, we have over 900 namespaces. I did not update the numbers. It's always growing. And AWS and Azure are the cloud providers beyond it. And the keyword here for my aspect on platform engineering last year was talking about the journey towards Kubernetes in the Deutsche Bahn. I'm still very attached to Kubernetes. And that's actually the technology that brings us the most potential to leverage these aspects. So Kubernetes is just the second biggest open source project of the world after the Linux kernel. I don't think I need any introduction in this conference here, so I will jump it. But one thing that we do is, of course, we already do with Kubernetes itself a lot of resource optimization. So we have node auto-scaling that brings efficient. We can have shared clusters with multiple tenants that enable a very high container density. But user applications are often still not optimized. So requested limits are set up conservatively because you don't want your application to crash. And anyway, there's project money that has already been estimated, so we don't care about it so much. Workloads run 24/7, even though you are only developing maybe 8 hours a day. And so in the end, you have a lot of waste. And Kubernetes, besides this optimization that comes out of the box almost, it also supports operationalization of GreenOps on multiple aspects. Because we have a lot of metrics that are being permanently collected, so really real time, you are able, based on these metrics, to do things like CPU and RAM request optimizations, to use an horizontal pod autoscaler that enables automated scaling of pod replicas, depending on your architecture. And also the vertical pod autoscaling, which is actually a very simple to use tool and enables the automated optimization of resource requests per pod. Then there's another aspect, which is workload scheduling. So you don't need to think at the end of the day to turn off your application. You can just annotate a workload with this cube downscaler, and it will, for example, on off work hours, just downscale your pods and not let it waste useful resources. So if we think on how this can scale, through workload resource optimization with the vertical pod autoscaler, we have currently 70% of average CPU utilization on our shared classes, but only 15% are really from the applications. So it's hard to say how much savings in the end is, but we can imagine the curve is more or less like this if we get a strong adoption of this vertical pod autoscaler. For the cube autoscaler, or cube downscaler, it's even simpler to estimate it. We have a saving potential from 49% CPU and 38% RAM. If we calculate the 75% is the proportion of out-of-office hours, and we take into account that development and test environments can just be turned off on off hours. Of course, that's not always the case, but that would be a potential. And if we make as default that when your developers go into the platform and they have a developer or a test environment, that is automatically turned off on off hours, then you generate automatically a change here. But we also want to improve this data model. So coming back to this idea, information and controllability that we want to have in the hands of the developers. We have started with a project because we said, okay, cloud providers are still not providing us with enough granular data. We need to join with we are also joining with other companies, with Siemens, with Allianz. There's an IT sustainability working group, very interesting if anyone wants to join. And we all are facing these problems, and we are actually also in dialogue with AWS and Microsoft so that they get us better data. But it's sometimes also difficult for them because business makes this type of data difficult to share, and they also have the problems in modeling their own data. But we started with Kubernetes clusters. And why we started Kubernetes clusters is because there's a project called Kepler, which, based on the energy information that comes from the processors and using then eBPF, gets data exported to Prometheus about the energy usage that is associated with a specific container. So it has a known model behind it to make this estimation. And this allows us to effectively get a kind of MVP where we say, this is the type of GreenOps that we want to make. This is real-time information on energy emissions. And we can then also couple it with CO2 emissions. There's this very interesting electricity maps, but there are also other APIs which you can use to say, at a certain hour of the day, how much is the CO2 intensity of my workload? And this allows us then to think, let's say, for example, machine learning training models, they require a lot of resources. And normally, most would say, I just will train my models when spot instances are the cheapest. But maybe when spot instances are the cheapest is when you have the higher carbon intensity. And if you have other factors, like reducing your carbon footprint of the applications that come into play, then you will also bring this into the equation and take this to decide when actually are you making the high-intensity workloads run on the cloud. And this fulfills the build and is the idea that we have behind. Not only an idea, but we actually have implemented Kepler. We have rolled it out, or we are about to roll out in our platform. So this is still a development environment from an OpenShift cluster. And it's a really simple tool to roll out. So you can really get this to the hands of your developers so that they start seeing it. And when they start seeing, they can start to act on it. And the interesting thing there is that also when you're developers, if you come from management and you just care about saving costs, you will still benefit from this. Because on one side, we rely on this intrinsic motivation of developers to save costs. If you go to the developers and say, can you optimize the workload because I want to save 500 euros at the end of the day? And they will say, yeah, but I will take 10 hours of my work, which costs 5,000 euros. So why do you want me to make this? But you don't need to ask this. You just rely on intrinsic motivation. I mean, why are you sitting in the session? Because most of you have interested for green. Some of you have interest for platform engineering. And we meet both sides. And we generate here a win-win situation. So I expect, and we are actually experiencing that more and more companies are bringing a focus towards green IT and GreenOps, because it's a win-win situation here in this case. We have a lot of challenges to address. So we still have no reliable data on energy usage and emissions from cloud providers, even more difficult from software as a service. But we know there are companies that also make an effort in creating their own models so that at the end they can say how much energy or CO2 you have generated. And the comparability between applications is difficult. There are some initiatives like the software sustainable, I forgot the name, but software carbon intensity, if you Google for it, it's on GitHub, that based on a functional unit, you can at least within your own application see how have you been optimizing or not, so that you don't only rely on absolute values, but also on relative values that depend, for example, on how many users are visiting website or how many API calls are being done, depending on the specificity of your application. And there are, of course, opportunities with this increasing role of ESG on investment decisions. There are partner networks from companies, and we have platforms, cloud native, and Kubernetes. So if you want to join us in this effort, of course, you can also do it in your company, but you can also join the DB Systel. We are always looking for people. And I thank you then for your attention and look forward for your questions.
Cool. Thank you, Gualter. Currently, I haven't got any questions, but if you do go onto the app or scan the QR code, we can take your questions. I'll give it a few minutes. Hardest part in making things green at Deutsche Bahn. Hardest part.
Hardest part. Well, I think the hardest part is to actually, so you have a lot of motivated people that want to do things, but they are all binded into projects. And so it makes it difficult to create a continuous project. So we need to start with these MVPs, convince that there's an interesting investment to be done, and then slowly gather actually the funding from portfolios, from research to go forward and build teams that address this specifically and build maybe products internally.
Cool. We do have questions. So the first one is, do you have the possibility telling about footprint reduction using ARM architecture instead of AMD 64?
Yes, this is possible to estimate. Well, you can use it, make in different ways. I'm sure there are studies that compare the energy usage, but if you would have run Kepler, it would take in consideration the type of processor that is behind. And with that, you can see that which savings are generated between one processor and the other. Also in the TEDS engineering that I've shown, you will have the different EC2 instance types. And you can there's a big Excel table on their website. So if you download this, you can compare the emissions of Intel Xeon, for example, with an AMD architecture and get some insights into it.
Next question is, how much CO2 do you emit digitally? I'm assuming you as in Deutsche Bahn, rather than...
Me personally? I have no idea how much CO2 I emit. Maybe the question was also how much do we emit on the cloud? Also, these figures I don't have. So the current measurements, what we get, for example, from AWS is that we have zero emissions because they use green energy, they have compensation mechanisms of carbon, and this is the information that we have at the moment. It's not the information we want to have as developers, of course. So we want to have more insights into it, and this is the reason why we are making this project.
Cool. How much do emissions and cost correlate for one application? Do I need Kepler if I have open cost?
Yes, you will need Kepler if you have open costs. The example I gave before, for example, you can have a spot instance that is very cheap in the night, to run in the night. But there is when we have the less solar energy generations, for example. So while it would be cheap to run your high-intensity workloads in the night, it will be environmentally more costly to run it. So it is important that we have both factors when addressing the decision on when to run workloads.
Cool. We're getting a fair few questions now coming in. Is there active support by public administration to align this work with the one on the SDGs?
I don't know about public administration. I mean, we are not public. We are a public private company, but there is a lot of, let's say, initiatives from the politics that percolate then into CIOs, and which then generate idea or objectives for the company that end up supporting this type of initiatives. So yes, we see a lot of support coming, at least from inside, from our tea resort, for example, with our board member that is actively supporting, talking about it, and also getting some fundings. So we are currently today also pitching for a future project for next year to continue our efforts here. So I would say, yes, there is support coming from top down because we want to know more about this, and also our boards and politics found these aspects to be important.
Cool, thank you. I'll go for that one. Scraping very granular metrics to enable the GreenOps approach incurs costs CO2. Was this included in the emission calculations?
You can actually also estimate this energy, again, of the application itself. So for Kepler, for example, it has an own container that is running and generating these metrics. I can tell you that, of course, if you have a very small, very small cluster, maybe this is not useful, but it's making a percentage overhead that's significant. But as soon as you have production clusters that are running several applications, it will really be a minimal impact. And I believe, of course, I still don't have this data, but I believe that the effect that it generates in enabling developers to control and to optimize is bigger than the overhead that it generates. Yeah.
Cool. I'll take one last question as we're running out of time, but do catch Gualter afterwards. So, how much time it took to integrate the tool in OpenShift, and how many teams were involved?
There was not even necessary to have a whole team. Well, one team was more or less involved, a part of the team, and I would say about 20 PTs per person days around this. You can get it done. Yeah. And even in a relatively complex environment like ours. So we are also, for example, making open source contributions. My colleague Bastian is there, so you can also talk with him if you want to have the technical details for it. And yes, so it will be even easier with the Kepler operator, for example. You can just roll it out and it works pretty well.
Cool. So nothing's really stopping you from implementing it.
Exactly.
Thanks again, Gualter.
Thank you very much.
Really interesting talk.